Look at the rendering of a modern luxury villa. Every angle is precise, the lighting is perfect, and the materials are flawless. This is the promise of premium interior design before a single hammer swings. But between that perfect digital blueprint and the day the client moves in, there is a gap, a chaotic stretch where disconnected vendors, scattered spreadsheets, and isolated teams make blind decisions on site. When the flow of information breaks down, the results are highly predictable. Budgets swell, schedules stretch by months, and the original design is quietly compromised to make up for lost time. Curious, how do you build a flawless physical space without relying on trial and error? HSI OS answers that by connecting the entire building lifecycle. It is a unified execution, decision, and sustainability platform that locks the digital plan directly to physical reality. The failures on a construction site almost always start months earlier in the planning phase, buried inside static, disconnected spreadsheets. HSI OS replaces those flat documents with BOQ intelligence. BOQ stands for Bill of Quantities, the master list of materials and costs. Here, it acts as an active decision engine, automatically calculating costs and linking every single material component directly to its place on the execution timeline. Before anyone signs off, the dual-layer design validation engine actively scans this entire network. It looks for complex errors, flagging violations against local climate rules, strict luxury standards, and material conflicts. The AI context layer immediately suggests optimal fixes, actively preventing impossible or overly expensive designs from ever making it to the actual construction site. Instead of waiting for a mistake to happen and then trying to fix it, the system corrects the plan before the materials are even ordered. A perfect validated plan is a great start, but it requires flawless execution on the ground to matter. When ground is broken, the platform deploys a digital twin. This is an exact virtual replica of the physical space that overlays real-time execution data directly onto the active job site. The digital twin tracks physical progress against a 4D time simulation, mapping the 3D space across the fourth dimension of time, showing exactly what components need to be built and exactly when. It visualizes hidden risks instantly. For example, it detects MEP clashes, which are physical intersections between mechanical, electrical, and plumbing systems, and resolves them virtually before a single pipe is cut and wasted on site. Operating invisibly behind this virtual replica is the Execution Intelligence Model, or EIM. The EIM processes real-time execution logs from the site to actively detect schedule delays, score vendor performance, and predict exact cost variances down to the dollar. Every success and failure is captured by the platform's learning system. It builds a proprietary database of vendor patterns and material behaviors, ensuring that a mistake made on one project is never repeated on the next. By pairing the physical site with a real-time digital counterpart and active analytics, the construction process shifts from constant triage into a predictable, self-correcting operation. High-end construction requires looking past the handover date. A truly premium property must account for the decades of living that happen after the builders leave. The sustainability intelligence layer integrates environmental impact directly into the planning process. Rather than passively reporting on emissions at the end of a job, it actively influences building decisions from day one. This chart shows the carbon footprint of specific building materials. The carbon engine calculates exact emissions for every individual item in the bill of quantities and immediately suggests low-carbon material alternatives. The intelligence extends to the wallet. This graph shows the life cycle costing model, projecting expenses over a 30-year span, proving the long-term financial return on investment when choosing sustainable materials today. These data-driven material swaps automatically ensure the entire project is compliance-ready for global green building certifications like LEED or IGBC. LEED stands for Leadership in Energy and Environmental Design, and IGBC is the Indian Green Building Council. Environmental impact is treated as a rigorous, data-driven framework that actively maximizes the property's lifecycle value. All of this intelligence converges at the project handover, where active construction ends and the final asset is delivered to the homeowner. The homeowner receives access to the client portal. This interface translates millions of complex execution data points into a clear, transparent narrative about how their home was built. Handover includes the physical keys and an immutable digital history, complete with full audit traceability and documented proof of material quality. The platform protects financial margins for the developer, preserves the pure design vision for the architect, and delivers complete peace of mind for the client. HSI OS operates as the invisible intelligence layer from the first blueprint to the final walkthrough, guaranteeing that every luxury home is built exactly as intended.